Welcome to our video on switching. In this video, we will learn about the important role switches play in networks. A switch connects multiple devices in a local area network. Unlike a hub that sends data to all devices, a switch sends data only to the intended receiver. This makes the network more efficient and secure. Switches work at the data link layer of the OSA model using MAC addresses to identify devices. In this video, we will explore how switches work, their types, and why they are important for modern networking. Let's get started. Switching in networking refers to the method used to transfer data packets between devices in a network. There are three main types of switching: circuit switching, packet switching, and message switching. Here is an overview of each type. In circuit switching, a dedicated communication path or circuit is established between two endpoints for the duration of the communication section. This path remains reserved for the entire conversation, ensuring a constant bandwidth. In packet switching, data is broken down into packets before being transmitted. Each packet is sent independently and can take different paths through the network to reach the destination, where they are reassembled. Message switching. In message switching, entire messages are sent from the source to destination without establishing a dedicated path. The message is stored at the intermediate nodes until the next node is ready to receive it. Among these three types of switching, packet switching is classified into two categories: virtual circuit approach, datagram approach. Here is a simplified overview of circuit switched networks. It consists of switches connected by physical links like wires or fiber optics. It works at the physical layer of the OSA model, which handle the actual transmission of data. It establishes a dedicated path between the sender and the receiver before any data transfer occurs. This process involves call setup, data transfer, and call teardown. Communication in a circuit switch network involves three essential phases: connection setup, data transfer, connection teardown. In connection setup process, it establishes a dedicated path between sender and the receiver. The sender sends a request to the receiver to establish the connection. The network identifies and reserves the record resources along the path. Once the connection is confirmed, both parties are informed that the communication path is ready. In the second phase, data transfer, it facilitates the actual communication between sender and the receiver. Data is transmitted continuously over the established path. Since the path is dedicated, there are no interruptions, allowing for smooth and constant data flow. And the third phase, connection teardown, it closes the established connection and releases the reserved resources. The sender or receiver signals that the communication is complete. The network terminates the connection, freeing up the reserved bandwidth for other users. In a packet-switched networks, data is split into smaller units called packets. The size of the packets can be either fixed or variable depending on the network and the protocol used. Packet switching networks are mainly classified into two types: datagram networks, virtual networks. Datagram networks, it is connectionless, no need to establish a connection before sending data. Each packet can take different paths to the destination. No guarantee that packets will arrive or that they will arrive in order. Commonly used for internet application like web browsing and email. On the other hand, virtual circuit networks, a connection is set up before data is sent. All packets follow the same route, ensuring they arrive in order. More control over data delivery and quality. Virtual circuit networks are suitable for applications needing a reliable connection, such as video conferencing or online gaming. Let us discuss about the datagram networks. Each packet is treated independently, meaning they are sent and routed separately. It operates at the network layer of the OSI model, where packets are routed. Even if packets are part of a larger message, the network treats each one as if it exists alone. This can result in packets taking a different paths to the destination. Packets are arriving out of order. Some packets may be lost. Even if the message is split into multiple packets, each packet is treated as separate independent message. Each packet can take a different route to reach the destination. Packets that are handled this way are called datagrams. Each packet in a datagram network has a destination address included in its header. This address is used by the routers to direct the packet through the network towards its intended destination. As the packet travels through the network, routers use the destination address to make decisions about which path to take. This allows packets to be forwarded independently, with each potentially taking a different route. Since packets in a datagram network may arrive out of order, each packet includes a sequence number in the header. This sequence number helps the receiving system to reorder the packets correctly, ensuring that the data can be reconstructed in the correct order. A virtual circuit network combines features from both circuit switched and datagram networks. Like a circuit switched network, it establishes a connection before data transmission begins. However, like a datagram network, the circuit is virtual, not physical, meaning multiple connections can share the same physical path. Some of the characteristics of virtual networks are: it is connection oriented. A virtual circuit is established before the actual data is transmitted, ensuring that all data flows through the same path. This results in in-order delivery of packets. Unlike circuit switched networks, the physical resources are not dedicated to a single connection but are shared among many virtual circuits, making the network more efficient. The virtual circuit network operates at the data link layer of the OSI model, where the data sends frames. Each frame contains a virtual circuit identifier, which helps routers and switches direct the frames along the pre-established path. In a virtual circuit network, the packets are called frames because the network operates at the data link layer. Each frame follows the same pre-established route, ensuring that frames arrive in order. In a virtual circuit network, a virtual circuit identifier is a temporary unique identifier assigned to each virtual circuit. The VCI is used instead of a full destination address to simplify and speed up routing. As frames move through the network, each switch along the virtual circuit reads the VCA and uses it to forward the frame to the next appropriate switch or router. The VCA is updated at each hop to reflect the next segment of the virtual circuit, ensuring the frame progresses along the pre-established path. In a virtual circuit network, each switch maintains a table with four columns divided into two halves. Inputs of input port number. This column indicates the port through which incoming frames arrives. Input VCI. This column contains the virtual circuit identifier associated with the incoming frame, helping the switch recognize which virtual circuit the frame belongs to. Output port number. This column specifies the port through which the frame will be forwarded. Output VCI. This column shows the new VCI that will be assigned to the frame as it leaves the switch, which may differ from the input VCI depending on the next segment of the virtual circuit. This scenario representing the source to destination data transfer in virtual circuit networks. There are three phases. The first one is connection setup. A virtual circuit is established between source and destination by signaling through the network. Each switch along the path assigns a virtual circuit identifier to manage the connection. In the second phase, data transfer. Once the virtual circuit is established, data is sent in frames. Each frame includes the VCI, allowing the switches to route the frames along the pre-established path. This ensures ordered and reliable data transmission as all frames follow the same route. And finally, connection teardown. After all the data has been transferred, the virtual circuit is terminated. This involves signaling to release the resources and VCA assigned to the connection, allowing them to be used for other transmissions. In a virtual circuit network, various delays can occur: connection setup delay, transmission delay, propagation delay, and connection teardown delay. Each of these factors contributes to the overall time it takes for data to be successfully transmitted from source to the destination. Connection setup delay. A delay occurs when establishing the virtual circuit as the network needs to signal through switches to reserve resources. Transmission delay. This is the time it takes to send data across the network, which depends on the size of the data and the available bandwidth. Propagation delay. The time it takes for a signal travel from the sender to receiver, affected by the distance and the medium used, for example, fiber optic or copper. Queuing delay. When frames arrive at a switch, they may have to wait in line if the switch is busy, adding to the delay. And finally, connection teardown delay. A delay occurs when terminating the virtual circuit as the network must signal to release resources. Message switching is a networking technique where entire messages are transmitted from sender to receiver without breaking them into smaller packets. Messages are sent to intermediate nodes where they are stored until forward to the next node or the final destination using a store and forward approach. There is no dedicated path between the sender and the receiver, allowing them to take different routes through the network, which can result in variable delays. It offers flexibility and can efficiently use network resources, particularly in unpredictable traffic conditions. It may introduce latency due to storage time at nodes and requires sufficient memory to hold incoming messages. Overall, message switching provides a flexible and efficient method for data transmission, but it can also lead to delays and storage challenges. Thank you for watching.